My name is Clément Quere. I'm a PhD student from University Côte d'Azur, and I'm glad to be here to present you our system paper named HandyNotes. So creating digital annotation to our world thanks to our hands. So with the collaboration of Aline Menin, Raphaël Julien, Wing Wu, and Marco Winkler. So creating annotation can be a challenge, and previous annotation system don't necessarily provide the best solution and have their limitation. That's why I'm going to present our approach named HandyNotes and the annotation process we have put in place to meet the various challenges. So we were fortunate enough to conduct a formative evaluation, to receive feedback, and support our future work on it. So annotations come from user intention to summarize and highlight critical elements in the written content, but also to enrich the content by, for example, adding subtitle to a video. But we can go more further by annotating a real object in our world thanks to mixed reality, because the technology facilitates the virtualization of annotation and seamless interaction with head-mount display. So, as I said, annotating a real-world object poses different problems, such as how to superimpose annotation to a world, or how to virtualize the object that we want to annotate, which type of annotation or support in mixed reality. So from this question, we have deduced different annotation steps, namely calibration of virtual environment, target creation, body content, and target body association, and finally visualization. So based on this annotation task, we reveal that among the existing annotation system in mixed reality, it offers a limit content type and never group this in one system. And most of them do not provide a clear information or how to calibrate the virtual environment. And we need an extensive investigation of the advantage and limitation of each technique. So in order to understand the changes related to the design of annotation in mixed reality, we propose HandyNotes based on the previous task, but in a specific order. So we need to calibrate the virtual environment so that digital annotation can be traced in our world. Then we need to create the target and the body. So the target is the elements that we want to annotate, while the body content often pretend to the target. So the fourth steps is the target and body association, and finally the visualization. So our system was made with Unity using mixed reality toolkit integration, and we use the Microsoft HoloLens2 headset due to a good tracking and gesture recognition, but also its media capture. So now I will tell you about the different possible implementation of the task and the lesson we have learned in the process based on 3 criteria. So the first one is articulatory distance is defined as a physical effort and is a physical effort between the interaction, and its meaning. And the second is semantic distance. It's the distance between the cognitive effort and the meaning of the expression in the interface. And the last one is if the proposed solution is feasible on HoloLens2. So, so there are 3 ways to calibrate the virtual environment. So the first is to use the GPS, but it's not support on HoloLens2. The second requires an high learning curve for the user to define the virtual room and then to annotate. So the last one, recommended by Microsoft, involve calibrating the virtual environment thanks to Quere code. So this flexible and lightweight solution has provided a feasible and has been successfully implemented in HandyNotes. So the second step is the target creation. So we have three approaches to create the target. So the first one is 3D object recognition, which is not possible due to the lighting condition in the environment. The second need the user to add linear curve to drawing the target and then annotate. And the last one, use a 3D library, allowing the user to choose an object and placing in the virtual environment. So we decided to choose this approach by using a bounding box as a virtual object. So next, after the creation of the target, we need to create the body by using two menu paradigms. So the floating menu is used for displaying the annotation, while the end menu system allows user to create the annotation. So through the menu, we need to create the content. We explore five types of content. So text, audio, video, pictures, and predefined tags. And so we decided to keep this technique, so menu plus content, in our approach due to the fact that each one is feasible and the previous annotation system don't support a variation of content types. So now we have created the target and the body. We need to associate them. There are three ways for the association part. So the first involves the user to create targets and bodies in any order, but need to identify which is the target and which is the body. So the second technique is to create the body, then the target. And the last one is to create the target, then the body. So we decided to choose the last one method because it's the most straightforward. So the final step of annotation is the visualization. So we have explored four approaches that we have implemented in the system. So the first one is displaying annotation as they have been created in the virtual environment. The second is visualizing the content through a list menu. The third is connecting target if they have links. And the final one is dynamically visualizing digital annotation next to the target. So now I will present you how we successfully add digital annotation in our world thanks HandyNotes through a maintenance task by placing annotation with instruction to repair a video projector. So the first step is to calibrate the virtual environment. So at the beginning, our application asks the user to scan a QR code. Then user need to create the target. We will use a bounding box to surround it. User can invoke this cube thanks a palm up gesture with his dominant hand and can perform geometrical manipulation on it, so translation, rotation, and scaling. So since the video projector is placed on the ceiling, the user needs to reach this position, so he needs to use hand ray gestures and place the bounding box at the same location as the physical object. So after the confirmation, the system took a picture as a first annotation. User can add the textual and audio description of the object. To do that, he needs to perform a palm up gesture with his non-dominant hand to show up the hand menu system and click on the different annotation buttons. So after the creation of the body, the system associates it with the target by displaying annotation through the annotation window. And finally, at the end of the processus, user want to verify the content of the annotation. To do that, he can bring the menu of annotation in front of him thanks to hand gestures and verify each annotation by clicking on it with index gestures. So when the application is closed, the virtual environment is automatically saved and it can be opened by other users to understand how to repair the video projector. So to evaluate our approach, we decided to conduct formative evaluation with 4 students. So they execute the previous described scenario, and at the conclusion of the experiment, each one fill a questionnaire based on cognitive and physical effort and give feedbacks. So each participant successfully annotate the virtual environment with an average of 20 minutes. So user found the direct touch more useful than the array for geometrical manipulation. Also, some users appreciate the hand menu system and report that over the time it can bring arm fatigue. So the HoloLens2 has limitations such as depth perception, also low field of view, and the ears with button lead to incorrect interaction with our hand menu system. So, and finally, 2 users report that our system lack tutorials to understand and perform hand gestures. So to conclude, we all contribute to the ongoing advancement of mixed reality technology by proposing an annotation system with multiple content types and a formative evaluation using HoloLens2. And we propose a design rationale to annotate real-world objects with a hand menu system. And finally, we are currently working on a new version of HandyNotes with user trials on the MetaQuest 3. And we would like to explore other interaction modalities such as voice command. So thank you for your attention. Do you have any questions?